चल रहा है ना, उसमें बैठा कुछ दोनों में क्या वैसे
Yes, sir. Good afternoon, sir. Yes, sir. Okay. Thank you, sir, for this introduction. And did you and sir is like that I'm speaking in my home, so I never bother about denying that I'm not available, because in home I'm speaking something, so that is not a reason that I had time or not. So for home I always have time, and sir was my teacher and also guiding me at this stage. And thank you for providing me this opportunity. So let us start the talk. So I will go a little bit slow because the topic will be new for most of you, and try to have some overview kind of things for these topics. If you are more interested, you can connect with sir or with me anytime with this topic. So let us begin. Hopefully my screen is visible. Yes. Okay. So as sir has mentioned, today I'm going to give a brief overview of federated learning for IoT. And what it will do, it will enhance privacy and efficiency in distributed intelligence. Okay. So before directly jumping to the topic of what is federated learning, what actually it did, let us have a brief overview of IoT, and then we will identify what is the need behind going to the federated learning concept, and why I am covering the topic of federated learning for IoT. Okay, so these are the two parts in which my talk will be probably dividing. First part, we will see IoT and its security challenges. So as you see here, Why I'm referring the security challenges, because in IoT mostly we will say a small form factor, low power, low processing capacity devices. So the chances of security compromise is very high in such devices. Though we are evolving with IoT, but we are not bothering about the security risks that may be encountered in day-to-day life. So how this security challenges associated with IoT is solved by federated learning, that we will try to unfold. So basically, before going to the definition of federated learning, let us just have an overview of what is IoT, and then we can continue. Okay. So directly jumping to the definition, if I say, so the term IoT is not a new term. You can see that it is not a term that arises in 2020 and after 5 years we are studying. It was a term that comes in late 2000, or you can say exactly in 1999. Kevin Aston has proposed this term, and they technically defined that the refer to uniquely identifiable objects and their virtual representation. So what actually they are referring that object here, when I'm saying that in case of Internet of Things or objects, so anything you can think could be the things, could be a human being, could be your laptop, could be your smartwatch, could be your watch of wristwatch, could be your clock, could be your refrigerator, could be the sophisticated tools used in the industry. So here thing or object is not limited to some particular class or some particular things. It is referring all the living and non-living beings that are accessible. Okay. So here it is defining IoT like that, how we can uniquely identify these objects. These objects or things, for example, now you can have also seen some water bottles are coming, they are showing the temperatures. So we are now also determining the temperature of that bottle. So in networks, if you think, so the representation of a human, the representation of a book, the representation of a copy is not as such, but they require some address mechanism. Because if you are going with an IoT concept, so you are going to insert some computing power, some memory, some processing power to a device. And if a device is enriched with such kind of things, so on internet they are accessible by a term that we know that is called IP addressing. So all the things are uniquely identified on the net. So first goal is clear. So Internet of Things is nothing but the internet of multiple things, or a things, a place where machine talks to machine, or things talk to machine, or a human talk to machine. So they need what? They need some unique representation. How uniquely we can represent our bottle, how you can uniquely we can represent our refrigerator, so that on the internet we can visualize what the things are happening inside the refrigerator, what the things are happening in our air conditioner. Now you have also seen some of the advertisements are coming that are depicting that you can control your air conditioner from your office. So how this is happening? Because when you send some command phone, it go to cloud, then from cloud it will identify the command is responsible for whom, so it will identify that it is your air conditioner. So it is not air conditioner of Rahul Mishra, it is mentioned that some IP address of that air conditioner the company has provided you, and now you can easily access the thing. So one thing is that in Internet of Things we are creating an environment, we are creating a scenario where objects, humans, non-living beings all are involved, and they are all available on the internet or interconnected via the internet. So they need a virtual representation. So first part is clear, and here it is saying in internet-like structure. This means that internet-like structure, because most of the things are transmitting data, we are capturing some information. For example, in your air conditioner nowadays, temperature sensor is placed, you set the temperature to 25. So now when your temperature goes below the 25, automatically the compressor is off. So that is also a form of connection. So here the connection is a wired connection. Okay, a sensor is sensing and transmitting the data. Similarly, when I control my home AC with my smartphone, then there is a wireless connection. So all sort of things are forming a net, and other is thing. So if these two things are there, then it is an IoT. And when we refer to things, so we refer some electronic devices. Okay, so now a question arises, okay, what sir is telling that everything can be a things, and now he is referring an electronics devices. So because when I refer a thing, so obviously there should be some devices to be implanted. Okay, for example, when I have to monitor the behavior of a person, so we wear a wristwatch or something. So that is an electronic component that are impaneled or installed on that things. Then we can get the behavior or the properties of those things. Okay, so this is the things, how things are becoming intelligent or computationally powered, because we are deploying some electronic devices, some chips, some microcontrollers on that things, and then we are connecting it with the internet. So two things now comes into the picture. One is that we have things that is capable of little bit processing, some memory, and also can convey its information wired or wirelessly to the internet or to the nearest devices. Okay, so internet of things is having two components. One is the electronic device and other is the internet. So this is a basic, if you say IoT is the internet of things. Okay, so things can be boundless anything, but it is only possible if it is things we are going to consider that where we can deploy some devices, electronic devices, to monitor its behavior or environmental impact and convey those information to the internet, and then only this whole thing, internet of things, form. Okay, now let us consider a simple scenario. Okay, so now we are changing speed of our fan via our remote or smartphone, let's say. So when you build a big computer to control your fan, so obviously the fan cost could be 3,000, and now while using this laptop or something, the cost raises to 40,000. And now you say that you will optimize everything and reduce the cost of this one, and so no one is going to buy your product. Okay, so who is going to buy your product? Let's say you make a small microcontroller, deploy everything on your fan. Now you can control from the smartphone. Initially the fan cost was 3,000. Now you claim it, the cost becomes 3,500, and it will save the electricity of 1,500 per year by optimizing through your wireless control or something. Then the person could buy. So you need some compact or small form factor computing unit to be attached with a thing or device we want. Okay, if we want to add a high processing power device or something to your things, then that is not acceptable, because then you will be in economic search, and that is cost ineffective. So internet of things provide a cost effective mechanism of monitoring things. Monitoring could be done in the form of environment, in form of their behavior, in form of our sleeping pattern, working pattern, vehicle movement. Anything could be a part of internet of things. So I hope you got a little bit idea. When I say IoT, that is nothing but internet of things. Things could be anything, but we have to deploy something to monitor it from a distant or directly on board it. Okay, so now moving on to the next. So if I summarize why this popularity becomes, because we have um, exponentially growth in the networking field, also from wired to now wireless to 5G, 4G, 6G things are coming. Similarly, our processing microcontrollers are now small form factors, cheaper in size. So both these factors has enhanced this internet of things, and now we have reached to a situation that we can deploy anything, anytime, any place kind of things. Okay, then connectivity for everyone. Okay, because we have reduced the cost, and also everywhere this market is now popularized. Growth of devices are on their higher end, and they are communicating with us. So our internet is better, our processing power is better, so no one can stop this. Okay, so connectivity for anything, what I was referring in the things, we can assume would be connected. So no one must have assumed that the health of a vegetable in your refrigerator can be monitored from your smartphone via some sensors, and your crop field far apart, you can see every instances at your smartphone and take decision accordingly. So these are the things. So that is connectivity for anything, connectivity for everyone. Okay, so anyone, any person, you want to connect anything you want to connect, so you can connect easily in a cost effective manner, in a small size, in a small form factor devices, and obviously it will be any time and any place. Okay, So for example, initially when the generation of computer begins, so we have a room size computer, so we cannot move from one place to another. Now we are shifting to the smartphone, that is moving from anywhere to any place, and through that smartphone we are connecting number of sensors and everything we are monitoring. Okay, so let us have a concrete definition of Internet of Things. Then what will happen? As a system of interrelated computing devices. How? So it is a system, fine. So it is a system of interrelated computing devices. So for example, I manage the AC temperature from my smartphone. So there is a interrelation. So interrelation is established by some protocols, because when I hit button 1, some signals will go, and accordingly the function of the AC will change. So that is an interrelation. And mechanical and digital machines. So obviously it is a mechanical or a digital machine, object, animal, or people. Anything you can see, that all covers. Okay. Second part comes, they are provided with a unique identifier that we have already discussed, that anything we want to refer in Internet of Things will be have some virtual identifiable address, that is called IP, and also has a power to communicate, to transport data over the internet. And here the one important thing is written, that human to human or human to computer interaction without required. Okay, so now we see that in case of let's say take a simple example of automatic washing machine. So it depending upon your cloth type, it automatically sense the cloth type, then pour the water accordingly, and it move the spinner accordingly, and you get the cloth. So the timing of your washing machine for from washing to drying is different when you put different types of cloth or different amount of cloth. So in all these process, no human intervention is involved. So that is there written, human to human or human to computer interaction is also not required. In some cases it is required, but in most of the cases it is not required. Okay, for example, your air conditioner is working. Okay, so when a temperature reaches beyond 25, you set 25, then automatically compressor will be on, and slowly, so there is no human involvement in such a case. Okay, so this is a diagram I have picked from internet, and you see it's your refrigerator is connecting, your light bulbs are connecting, the dishwashers are connecting.